Today we're going to use 3 lasers and try to measure some things that are very small, like hair. Let's look at the setup. You can see the green laser there. It's actually pointing at a fishing line which is next to a hair, and then got this long meter stick taped to, well, not a long meter stick, but a meter stick taped to another meter stick. So that way we can figure out the big distance from the laser to the board. And looking in at the meter sticks, of course that's 1 meter, and then I flip the other one around, so it is 78, 79, so 1.79 something or other. Look at the end of that meter stick. Let's take a look at the other end. I'm going to mess up here, but let's see over here someplace. Look at the other end. I got these new meter sticks, and they have on the end of them, look at that, like maybe a couple 3 millimeters plus or minus. So I thought it was 179.3 centimeters. So you'll have to figure that out, like if you want to use my adjustments or not. So here's our data. I haven't really put the uncertainty on the big distance, but this is the data that we're going to use. And then we'll turn off the lights and see what happens when we shine lasers on these thin objects. That first one was a fishing line, the second one was a hair, and then we'll continue to look a little closer at this. And what we're trying to see are these almost dotted lines, these minimum and maximum interferences when the laser wraps around these tiny objects. Now I'm shining it here on a piece of thread. Thread is too thick for the laser to see. But when I hit the, let's see, which one is this? We'll go back to that. There it is. When I hit the fishing line, you can see it's dotted. And then I'll try to go back. There we go. I'll try to go back to the hair, and you can see that even thinner objects give more distinct minimum and maximums. Thread, nothing. Hair, good. There's the hair. And fishing line, voila. Yeah, looks pretty good, right? So there's the fishing line. Now I'm going to switch up to a different color laser. And I'm sorry to say this, you're just going to have to trust me on this because the camera wasn't that great. But there, I'm hitting the hair again with a different color laser with a different wavelength. And it does produce a faint line in there, and the line is not as beautiful as the green laser because the red laser isn't as powerful. But it does produce some repeating patterns. And as I go through and try to shine it on the thread, let's see if I can get it. Now that second dot is just a weird part of the laser, but anyways, so try to shine it on the thread, and the thread doesn't really do a good job there. Let's take a closer look. Let's see. Oh, you can kind of see. Oh no, this is the hair, because you can see the repeating dark pattern there, just a little bit as it goes from the central maxima out. We'll take another look at it again. Yeah, I tried it again, but I just couldn't get the video to work very well for you, so you're going to have to trust me on this. But let's just change it up. Let's get out the UV light. Okay, so the UV laser, oh my gosh, it hits the board and shines back, and it's very bright. And I did get it to on the, let's see, this is the fishing line. And the fishing line made a line, but I could not see distinctive minimums and maximums. No bright spots, no dark spots on the side of it. So I don't know if it's just a property of the fishing line or not. So here it comes again. Yeah, you can see kind of a line, but there's no minimum and maximums, and that's what we were looking. So we'll just, the UV light didn't work. So you can pause the video and look at the data here, but I already went through and did the measurements for you. So you'll see there, let's look at the top left-hand corner, n equals 6. That means I counted out 6 of the repeating dark and bright spots, and that was 4.3 centimeters. And let's take a look at it again. And you can use this data and come up with some numbers and calculate maybe the thickness of fishing line and the thickness of hair and maybe the thickness of the thread with only the green line. Okay? let's take a look at the relationship that you're going to use. It's the little d that you're looking for. And you can do this in centimeters, but you have to do some unit conversions. But the lambda, of course, is the wavelength. The n is the number of minimum maximums that I counted out to. The big D is the big distance from the board to the laser, and the S is the distance of the actual minimum maximum. So you have to do some calculating there.